Hello everyone, I am Monica from the Department of Mathematics, SNS College of Engineering. Today we are going to see testing hypothesis. In this I am going to take t-test. So before entering into t-test, we should know what is large sample and what is small sample. So if you are having a sample size as 30 and above means that is your large sample. If you are having sample size as 29 and below means you have to go for small samples. In small samples we are having three types. One is t-test, another one is f-test, another one is chi-square. So if you are having the data based on the average means you have to go for t-test. If you are having the data based on variance means you have to go for f-test. If you are having observed frequency and expected frequency means you have to go for chi-square. Now we are going to move into our problem. First, before entering into this problem, we should know we are having two types in t-test. One is single mean, another one is double mean. That is, from the population, if you are taking only one sample means we have to take that as a single mean problem. If you are taking two samples from the population means we have to go for the difference of mean. The first problem is a random sample of 10 boys have the following IQs. We are having some data based on IQs of the 10 boys. Do this data support the assumptions of population IQ of 100. Find a reasonable range in which of the mean IQ value of the sample of 10 boys live. So we are having 10 boys. So for them we are having some IQ levels. So overall population IQ is 100. So we have to check the sample IQ level is matching with the population IQ level. For that we should know what is our N. N is we are taking here one sample, but in that sample we are having sample sizes 10 boys. So our N value is 10. So this is 29 and below. So we have to move for small sample. Then we should know what is population mean. Population mean is denoted by the parameter mu, that is 100. Then x bar. We all know the x bar formula is summation x by n. So we have to add all those data and have to divide by 10. We are going to get 97.2 as x bar. Then we should know what is s square formula. Summation x square by n minus x bar by whole square. For the each value we have to take square and have to divide by 10. So already I have the data as x bar value. We have to upload all those values here and have to get 183.36 as your s square. From this we can get s by taking root of this value. Then we have to move for the procedure. We are having 5 steps to complete this problem. First we have to fix H0, H1, alpha. Then we have to go for test statistic. Then we have to go for the conclusion. So our H0 is mu is equal to 100. Then H1 is we have to take opposite for that, mu is not equal to 100. In this problem there doesn't give the LOS value. So we have to take default as 5%. Then we have to move for degrees of freedom. Degrees of freedom is formula is n minus 1. Here n value is 10. 10 minus 1 is 9. So based on these two things we have to go for the t-test table. So in that we have to take degrees of freedom is 9. Then LOS is 5%. So we have to measure that value is 2.26 here. Then we have to move for the test statistic. This is the formula x bar minus mu by s by root of n. We are having all those values. We have to substitute here. We are getting here minus 0.62. Then we have to move for the conclusion based on the table value as well as calculated value. Always we have to get calculated value less than table value. If you are getting less than means we can say here H0 is accepted. Otherwise we have to say H0 is rejected. So we are having here Z value is minus 0.62. If you are having any negative value means we have to take modulus for that. It will be turned as 0.62. Then 0.62 is less than 2.26. So this problem is accepted. H0 is accepted. Then we have to move for the second problem. Two independent samples are chosen from the two schools A and B. A common test given in a subject. The scores of the students are as follows. So they are considering two schools. They are making one test as common for the two schools A and B. Finally, what we have to conclude as students of school A performed better than students of school B. So we have conclude A students A school is better than students B.